Alright, so we can go ahead and bring up a rule. And I want to bring up the rule because I'm going to be applying it for this problem. Yep. Okay, so start by rewriting the problem first before I differentiate. And this is equivalent to 1 over ln 8 times ln x squared plus 3x. And the reason I want to do this is so that when I differentiate, I treat this here like a constant because it technically is. This is just like a number. So you're allowed to do that, and what I mean is that I'll prove that by showing an example. So like x7 x squared, they ask you to differentiate this. You can rewrite this so it's like this, and then that would give you 7 times 2x, which is 14x. But most people, they just like go ahead and skip all that and go straight to 14x, which makes sense in most part, but it's good to know that what this rule is and when to apply it. So here would be when you could apply it. So continuing on, let's go ahead and differentiate. And then the derivative of x squared plus 3x is 2x plus 3. Then our answer is going to be 2x plus 3 over x squared plus 3x and ln 8. That right there is our final answer. So for this problem, I want to bring up this rule because I'm going to use this one here. So let's go ahead and start first by rewriting. And I'm just going to use the same strategy I did the last problem, bring out this ln 10 outside. Then let's go ahead and differentiate. So now it's going to be 1 over secant, and the derivative of secant is secant times tangent. And our secants are going to cancel. And our final answer is going to be tan x over ln 10. Let's moving on. Let's go ahead and start by differentiating. It's going to be 1 over ln x times the derivative of ln x. So derivative of ln x is 1 over x, so this problem is just going to be 1 over x ln x. All right, so for this one, we're going to go ahead and use a product rule. And I'll go ahead and draw out the product rule here. That right there is the side product. I meant quotient rule. Yeah, that's the quotient rule that I'm going to be applying here. Derivative of ln x is 1 over x times 1 minus x minus derivative of 1 minus x is just negative 1 and ln x. It's going to be 1 minus x squared. And then I'm going to go ahead and distribute the 1 over x. And I think this is called an improper fraction. Or so when there's a fraction within a fraction. So I'm going to go ahead and... it's not an improper fraction. There's another name for it. But I'm going to go ahead and get rid of it by multiplying both the numerator and the denominator by x. So if I multiply 1 over x by x, it's just going to be 1, and then I need to multiply all the terms. So 1 minus x plus x ln x. And I also have to multiply the denominator, so it's x 1 minus x squared. So then that right there is our answer. Well, let's go ahead and start off. This is going to be the product rule. So I think that's a wrong notation. You can't use dy over dx if you have f and g. My bad, guys. So it would be That's a product rule. So let's go ahead and apply it. I'm gonna write it out simply so that I can show a couple steps because this one is kind of complex. And then the derivative of 2x, it's going to be 2x ln 2. The reason why is because there's a rule. It's like if you have y equals 2b, then dy over so it's going to be 2b times ln b. Yeah. No, that's wrong. That's wrong. That is wrong. That's the correct rule. There you go. Okay. So I did that. Then this is first term log 2x plus the derivative of log 2x is one over x ln x. The reason why is because there's also a rule for this one. It's go ahead and write it out. It's y equals log b of x, and then y prime would be x ln b. Yeah, these are the rules. Okay, moving on. Let's go ahead and simplify a bit. So I'm just rewriting this log 2x here as ln x over ln 2 plus 2x over x ln 2. From here, forgot to cancel this out. So yeah, they cancel. With ln x plus 2x x ln 2. Okay, moving on. So for this one, this is definitely one of the more complex problems, but we have to use the rules or else it would be so hard to differentiate this. You would need like a calculator, like not like a normal calculator, but complex calculator. So the rules that we're going to be using, they are like if you have ln, L, bro, ln a over b is equivalent to ln a minus ln b. If you have ln a times b, just be ln a plus ln b. And if you have ln b to the x, it's equal to x ln b. So using these three rules, we're going to go ahead and split this one up. Split this problem up into bite-sized pieces. Okay, so applying all the rules, our problem is going to look like and I won't like simplify all at once. I'll do it like steps at a time, so it's easy to digest these bite-sized pieces. So this right here, it's like equivalent to 1/3. So we're going to go ahead and use the exponent rule for that one. Okay, now we can go ahead and differentiate. Derivative of ln x is 1 over x. Derivative of this is going to be 4 times 1 over x squared plus 1 times the derivative of x squared plus 1, which is just 2x, minus 1 over 2x minus 1 times the derivative of 2x minus 1, which is just 2. Let's go ahead and combine like terms and such. I need to cancel stuff out. Okay. Cancel. And then from there we can get rid of the ones. So cool, that's our answer. Moving on. This right here, you can, the absolute value sign, you're still gonna differentiate it like you normally would. So that will give us negative 10x to the fourth. That right there is our answer. All right, let's go ahead and start. Times so the derivative of cosecant x is negative cosecant x cotangent x. And then the derivative of cotangent x is negative cosecant x. That's cosine. Cosecant squared x. Right. And then so since double negative, those cancel, making it a positive. And let's go ahead and simplify. How do I want to do this? Okay. Yeah, so I'm just going to factor out a cosecant. And can cross it out. And our answer our answer is going to be cosecant okay, moving on. Okay. I'm just going to start by simplifying first. Y equals ln. I'm going to factor out an e to the x. E to the negative x, sorry. From 1 plus x. And then I'm going to go ahead and differentiate this. So, well, no, because we have that rule, our ln rule, where if they're multiplying, then you can, I'll just write it out. Ln e, they undo each other, so just negative x plus. Here you can go ahead and differentiate. Then can make this a single fraction. And that's our answer. All right, so for this one, these terms right here, these are exponents, just in case it's not clear. So so the derivative of like e to the u is just going to be e to the u times du over dx. Yeah. I think this, I think that has to be u. Wait. I don't know the notation, but that's the rule. So this is going to be the product rule. Derivative of x squared is 2x times ln x plus x squared times derivative of ln x, which is just 1 over x. Times 2x ln x plus x. That right there is our answer. Same thing with this problem. Minus x squared plus. So that's going to give us 2x plus 1 over x. Again, I'm going to go ahead and rewrite this. And now we can apply our logarithmic rules. So okay, now I'm going to go ahead and differentiate. It's going to give me I'm going to go ahead and simplify a couple steps in the differentiation process. So there's a 2 here, and it's going to cancel out with both the 2's there. Just going to go ahead and cross that out. Because if you distribute the 1/2 to each term, the 2's cancel. So that leaves us with 1 over 1 plus 2x plus. Let's get a common denominator going here. So it's going to be 1 minus 2x times 1 minus 2x, or 1 minus 2x over 1 minus 2x times 1 over 1 plus 2x plus 1 over 1 minus 2x times 1 plus 2x over 1 plus 2x. And this is going to go ahead and give us 1 minus 2x plus 1 plus 2x over 1 plus 2x times 1 minus 2x. Let's go ahead and do one more step. 2 over 1 minus 4x squared. Boom. Okay. This one. Let's go. So I'm just going to be using this rule. N log A. I wrote the rule earlier with B, so I'll go ahead and use B again. Oh, it's sloppy. Log A to the N equals N log A, and log, I just said I was going to use B and I used N. Log A over B is equal to log A minus log B. Is it log or ln? Oh, this one is ln. Okay. And our derivative is going to be A over x minus ln b. And our final problem. Start by using our rules. I just did like 4 rules back to back to back to back. And I can do one more. So this, the denominator ln2, I'm just bringing it outside as a fraction. Okay, so how I got from this step to this step, um, I'll write it out. So that's why I have log base 2, 5 here. Because this right here and here, they're equivalent. And here, I just brought it out as a fraction. That's what happened. Okay, so now we're going to go ahead and differentiate. And go ahead and bring it to the top. So and then down here, the derivative of log base 2, 5, this is just a constant, so it's going to be 0. Oh, we got it. Final answer. Let's go. All right. Thank you for watching.